platelet a type of cell? No. Remember, platelets are not cells. They're fragments of former cells. Okay, so they're cell fragments. In other words, they were part of a cell at one point called the megakaryocyte, which I don't care about right now. But platelets are parts of cells. Okay, they are not cells. They're involved in clotting, so you want to remember that. Platelets are involved in what? Clotting. And they circulate in blood for how long? 9 to 12 days. How long is the lifespan of a red blood cell? 120. How long is a light cell of a platelet? 9 to 12. So which one lasts in the blood longer? The platelets, which are 9 to 12 days, or the red blood cells, which are 120? Red blood cells. Red blood cells are 120 days. By the way, how many months is 120 days? 4 months. How many days is 120 days? 4 months. How long do platelets stay in the blood? So 9 to 12 days. How many days? 9 to 12. So about a week to 2 weeks. Okay. Do clots temporarily patch blood vessels? Yes, they do. They patch blood vessels. How many phases are there to hemostasis? 3. What does hemostasis mean? Blood clotting. What does hemostasis mean? Blood clotting. So what happens is if you have a blood vessel here, okay, let's say that's a blood vessel, okay, and you get a cut. So this is literally what happens when you get a cut. When you get a cut, the following happens. Okay? So what happens? The blood that's inside, let's see if we can do this, the blood that's in here starts to leak out. Okay? So we want to stop that. What stops that? Do platelets help stop it? Yes. So the platelets will form right here, and right here, and right here, and right here, and right here, right here, right here, right here, right here, here. So those are the platelets. Okay? So how many phases are there to blood clotting? 3. How many phases are there to hemostasis? 3. Is hemostasis and blood clotting the same thing? Yes. Is hemostasis and blood clotting the same thing? Yes. Is hemostasis and blood clotting the same thing? Yes. What's another word for blood clotting? Hemostasis. What's another word for blood clotting? Hemostasis. What's another word for blood clotting? Hemostasis. How many phases are there to hemostasis? 3. What's the first called? Vascular. Does the vascular take place first? Yes. What's the second phase that occurs second? Platelet phase. And what's the third phase? Coagulation. So VPC. So Vice President Costa. How does that sound to you guys? Okay? Vice President Costa. Okay. So VPC is how you remember hemostasis. So just think of this. There's no way that I would ever give a dime of my blood to be vice president. I don't know if that helps it. Okay, you'd have to stop me from it. Vascular phase. Okay, what happens during the vascular phase? Endothelial cells. Now remember, you do have to remember this. Endothelial cells are simple squamous epithelia. So in other words, for simple squamous epithelia of a blood vessel, okay? And guys, for those of you who don't know what a blood vessel is, blood vessels include arteries. I'll just put artery, vein, capillary. So all of those are blood vessels. Okay, so artery, vein, capillaries are all blood vessels. In other words, that's what's inside our body that carries blood. Okay, blood's either in an artery, a vein, or capillary, and all 3 of these are connected. So back to this. What's another way of saying endothelial cells? Simple squamous epithelium of a blood vessel. What's another way of saying endothelial cells? Simple squamous epithelium of a blood vessel. What's another way of saying simple squamous epithelium of a blood vessel? Endothelial cells. What's another way of saying simple squamous epithelium of a blood vessel? Endothelial cells. Excuse me. During the vascular phase, do endothelial cells contract? Yes. Do endothelial cells become sticky? Yes. Does smooth muscle contract? Yes. So are there 2 phases of contraction here? Yeah. So contraction, whether it's of endothelial cells or smooth cells, occurs during what phase? Vascular. So contraction occurs during what phase? Vascular. During what phase is contraction? Vascular. Okay? In what phase do endothelial cells become sticky? Vascular. So sticky is what? Vascular. Contract is what? Vascular. So why not remember it that way? Let's just say sticky and contract is what phase? Vascular. So sticky and contract is what? Vascular. What's the second phase? Platelets. Platelet phase. During the platelet phase, do platelets attach to the endothelium and each other? Yes. So let's say attach. Okay, so platelets attach. Platelet phase is what? Attach. Platelet phase is what? Attach. What's platelet phase? Attach. What's platelet phase? Attach. What's vascular phase? Sticky and contract. What's vascular phase? Sticky and contract. What's vascular phase? Sticky and contract. What's platelet phase? Attach. What's platelet phase? Attach. What's platelet phase? Attach. Which is attach? Platelet phase. Which is attach? Platelet phase. Which is sticky and contract? Vascular. Which is sticky and contract? Vascular. What's the third phase? Coagulation. What's the third phase? Coagulation. How do you remember the phases of hemostasis? Vice President Costa. How do you remember it? Vice President Costa. What does the V stand for? Vascular. What does the P stand for? Platelet. What does the C stand for? Coagulation. Good. Now, this is all the coagulation phase. Okay, so just think to yourself, the coagulation phase is going to include the chart. So the coagulation phase includes the what? Chart. So in other words, the C in coagulation should hopefully remember what's this whole chart here. Okay, the whole thing. How many pathways are there total in the coagulation phase? 1, 2, 3. Now, I'm not going to ask you how many phases there are. Excuse me, how many pathways there are. I will ask you the phases. But I won't ask you how many phases are there. I'm just doing it to make it hopefully a little bit easier for you. Okay, so the two starting pathways are what? Extrinsic and intrinsic. That you want to know. Okay, where does extrinsic occur? Outside the blood vessel. So extrinsic occurs outside the blood vessel. So this is in the blood. So this is the plasma, actually in yellow. That's what it's trying to represent. And everything here is a simple squamous epithelia cell. Everything outside of that is outside of the blood. So if it occurs outside the blood, what pathway is starting? So in other words, if the cut gets down to here, which it does, you can see in this picture, this is where the endothelium would be. So let me just erase that. That's where the endothelium would be. But you can see that it broke, right? So if you see that it broke, then what does that mean? It means it's starting out here, okay? Starting right on the outside. So that's extrinsic. So if it occurs outside of the blood vessel, it's what? Extrinsic. If it occurs inside the blood vessel, which is right here, that's intrinsic. So in a cut, extrinsic and intrinsic will both happen, okay? It's not either or. In extrinsic and intrinsic, do both occur? Yes. In intrinsic and extrinsic, do both occur? Yes. Or let me rephrase that. In a cut, does both intrinsic and extrinsic occur? Yes. Do both pathways occur in a cut? Yes. What's the one when it starts outside? Extrinsic. When it starts on the inside, it's what? Intrinsic. Do both of these happen when we get a cut? Yes. Okay? Now, next thing. Vitamin K. Okay? Is vitamin K necessary for the extrinsic or intrinsic? Well, remember, guys, everything on this side is extrinsic. Just drawing a line. Everything on this side is what? Intrinsic. So the vitamin K is on your left side. So is that part of extrinsic or intrinsic? Extrinsic. Okay, so remember K-E-V-I-N, Kevin. Seem to have a lot of examples about myself today. K-E, okay, K is vitamin K, and E is for what? Extrinsic. Okay, so Kevin, K-E. So vitamin K, is that involved in extrinsic or intrinsic pathway of clotting? Extrinsic. Now, is this part of hemostasis? Yes. What phase is it? First phase, second phase, or third phase? Third. How do you remember the three phases? Vice President Costa. Vascular, platelet, and coagulation phase. Okay? Next, vitamin K. Where is it found in? Leafy green vegetables. Where is vitamin K found in? Leafy green vegetables. What bacteria uses the leafy green vegetables to produce vitamin K? E. coli. What's the name of the bacteria? E. coli. So what's the name of the bacteria responsible for producing vitamin K? E. coli. Is vitamin K necessary to cause a clot? Yes. Are leafy green vegetables necessary to form a clot? Yes. Is calcium required to form a clot for both the extrinsic and intrinsic pathways? Yes. Is calcium needed for both extrinsic and intrinsic pathways of forming a clot? Yes. Okay. Where do both of these finish? At what factor? Factor 10. Okay. Factor 10 is going to become what? Prothrombinase. Excuse me, going to activate what enzyme? Prothrombinase. What is factor 10 going to activate? Prothrombinase. Is prothrombinase an enzyme? Yes. What is the function of prothrombinase? Converts prothrombin to what? Thrombin. What does thrombin do? Converts fibrinogen into what? Fibrin. And then what are these blue little lines there? They're fibrin. Does fibrin keep the platelets stuck together? And the answer is yes. Okay? So, how many total pathways are there? 3. On the left side, is that extrinsic or intrinsic? Extrinsic. Which one's on the right? Intrinsic. Remember in the alphabet, guys, E is on the left side, I is on the right. E comes before I. Okay? Is vitamin K necessary for extrinsic? Yes. Is vitamin K necessary for intrinsic? No. Is vitamin K necessary for intrinsic? No. Is vitamin K necessary for extrinsic? Yes. How to remember that? K-E-V-I-N. Now, what bacteria produces vitamin K? E. coli. What bacteria is responsible for producing vitamin K? E. coli. What bacteria is responsible for producing vitamin K? E. coli. What does E. coli use to generate vitamin K? Leafy green vegetables. What does bacteria E. coli use to produce vitamin K? Leafy green vegetables. Okay. Is calcium needed? Is calcium needed in both pathways? Yes. Is sodium? No. Is potassium? No. Is calcium? Yes. Is vitamin K needed in the extrinsic pathway? Yes. Is calcium needed in both extrinsic and intrinsic? Yes. Are clotting factors needed in both? Yes. Is tissue factor needed in both? Yes. Both the extrinsic and intrinsic pathways come together at factor 10, correct? What does factor 10 do? It activates the enzyme prothrombinase. What does factor 10 do? Activates prothrombinase. What does factor 10 do? Activates prothrombinase. What does prothrombinase convert? Prothrombin to thrombin. And yes, guys, you have to know this, okay? My suggestion is write it down, but write it down shorthand. You don't have to memorize all these words. What I would do is put 10 here, okay? Put P, ACE, okay? And then what does PACE do? It converts prothrombin to what? Thrombin, okay? And then thrombin converts what? Gen to what? Bonus points for Microsoft. Come on, email, I don't want this now. To fibrin. Okay? Guys, that's the way I would do it. I mean, just do this. Again, X, PACE. Okay? Let me do it up. Let me erase that. Okay, so let's try it again. 10, we're just talking about the common pathway. 10 converts what? It activates what? It activates what? PACE. And what does PACE do? Converts prothrombin into what? Thrombin. And then what does thrombin do? It converts fibrinogen, or if you want to put FGen, to what? Fibrin. And then fibrin is the glue that holds the platelets together. So what holds platelets together? Fibrin. What holds platelets together? Thrombin. Fibrin. What holds platelets together? Fibrin. What holds platelets together? Fibrin. Okay? What is responsible for converting prothrombin into thrombin? Prothrombinase. What converts prothrombin into thrombin? Prothrombinase. What does thrombin do? Converts fibrinogen into fibrin. What does thrombin do? We'll do it up here. What does thrombin do? Converts fibrinogen. Is that right here? Converts fibrinogen into fibrin. What's the glue that holds the platelets together? Fibrin. What holds platelets together? Fibrin. What holds platelets together? Fibrin. What holds platelets together? Fibrin. What activates prothrombinase? Factor 10. What activates prothrombinase? Factor 10. And what turns off a clot? Antithrombin. What turns off a clot? Antithrombin. And that's it, guys. That's your review for blood.